Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. Today, I would like to show you how to use a simple text file and make changes to the solver settings during runtime when running the Fidelity LES solver. When running large eddy simulations, it is common practice to not save the entire solution at numerous time steps in order to reduce the disk footprint and only save relevant data that would be useful later for post-processing. However, this could lead to situations where the user did not anticipate the need for a particular data set before launching the simulation, and so it was not included in the initial post-processing setup. In these cases, instead of stopping the solver, changing the input file, and restarting the solver again, which might not be an easy process in a HPC setup, the Fidelity LES solver simply allows the user to add as many post-processing probes as they desire during runtime. To do this, the user can create a killcharles file and enter the commands that are needed to set up the post-processing probes. The syntax for these commands is exactly the same as it would be when used inside the solver input file. The solver periodically looks inside the computation directory for this killcharles file, and once it finds it, the solver will read the contents and delete the file. In this example simulation, the solver input file contains the commands to save 2D contours of the instantaneous static pressure at a particular cut section at regular intervals. Currently, the solver is running in the background, and let's say that the user is also interested in the average static pressure at the same cut section. To extract this data, they can simply copy the command for the instantaneous pressure into a new file, quickly change the variable to average static pressure, and save it with the name killcharles inside the computation directory. The user can then verify if the solver has correctly read this information by looking at the log file of the simulation. In addition to including post-processing probes, it is also possible to change a few of the solver settings. These include changing the time step of the solver, either by defining the CFL or the DT, pausing the solver, saving the solution at the current iteration, and stopping the solver. For example, this simulation is currently running with a CFL of 1, and the user might be interested in speeding up the convergence by increasing the CFL to 2. It can be done easily by just adding the line timestep CFL2 to a text file and saving it with the name killcharles inside the computation directory. Since this is a very simple command, it is also possible to quickly do it through the terminal window using the echo command. Obviously, since the solver takes a much larger time than the mesh generation process, runtime modifications are more useful when running the solver. However, it is good to know that the Fidelity LES meshing tool called Stitch has its own killstitch file which works in the same way as the solver. The user can add commands for extracting images of the mesh while the mesh is being generated. And in some cases, it is useful to add the interactive command to the Stitch input file before the final mesh generation step so that the user can inspect the mesh and also check if the number of control volumes to be generated is within their expectations. Once the user is satisfied, they can use the killstitch file to pass the hold off command, which instructs the mesher to process the next commands in the mesh input file. With this video, I hope that you have gained some insights on how to use the killcharles and killstitch file in your Fidelity LES projects. Thank you for watching. If you like this video, be sure to click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments, or suggestions, drop us a line below or connect with us via LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.